So we're doing 11.4 from our algebra. And this problem is going to look like a different kind of problem until you realize what you're really looking at. So go ahead and get a copy. So here's my question. That little dot right there, Taylor, what does that mean? Right, there's a multiply sign. If I was to take my eraser and get rid of the multiply sign, what would still be happening between the numbers on the top and across the bottom, Lindsay? Yes. So you have to accept that this problem is just a multiplication problem. Just because I wrote it as two fractions, it's still just 14c to the fifth, 2c to the third. It's the same. It's just a multiply problem. You just multiply the top, multiply the bottom. Don't overthink it. And now from this point, you would need to just do the simplifying that you would do. Technically, you can simplify before if you wanted to. If you wanted to start canceling stuff out here, you could. So I'm going to reduce my 14 and my 2. I'm going to divide them both by 2 and get a 7 and a 1. And then what's that final answer going to end up looking like? Think about what your C is going to get you. Daniel, what do you think? That is correct. And because there would be nothing left on the bottom, I'm not going to put anything. And as of right now, this particular section does not ask you to state the exclusions all the time, so we're not going to state them today. In the homework, just read it. If it says do it, do it. If you don't have to. But there wouldn't be any anyway because there's nothing in the denominator. Here's our next one. Again, this is we've already been doing this, so don't. It just looks like it's a bigger problem. That time sign. Pause. And if you wanted to, you could start zapping stuff right now. If you wanted to zap those two y's and zap the 3's and zap, you could do all that, which is fine. I'm going to go ahead and be consistent. I'm going to go 6x to the third, y to the second, over 12x to the second, y to the second. I'm just practicing multiplying. But you could have reduced early, because you can when you're multiplying with fractions like that. It's called cross-canceling. Okay, so this one I'm doing the longer way. So that's, I'm dividing by 6, so I get a 1 and a 2. My x's, I'm going to have an x left up on top, and my y's are gone. So I got left with 1x in the numerator, and I have a 2 on the bottom there. This one would have no exclusions either, because there's no variable on the bottom, so it would have no exclusions. This multiplication, you could pre-reduce, and that's what we'll do on this one. It's called cross-canceling. Okay, so here's an example of one that we could actually do the reducing first. This 3 and this 12. Notice one's in the numerator, one's in the denominator. They're both divisible by 3. So zap 1, zap 4. I just reduced each of those numbers by 3. I could also look at my t's and realize that this t is going to be gone, zap. This t is going to turn into just a plain old t. The exponent will be gone. Right, because it was 1 here and 2 there, so I did my subtraction. So now when I get a final answer, I got an m squared on top and a t. And down here I'd have a 2 times a 4, and I'd get an 8. And this would be my answer. So that's reducing before you actually multiply. Again, I personally don't like that method, only because our next one, they're going to get a little different. Let's see if I can come up with that 3, so 4. I try this one on your own. Okay, so I am going to go and multiply these. I'm not going to reduce. I'm going to go ahead and get 60, x to the fifth, y to the third. You can do it the other way and see if you do the same thing. And I got a 40, x to the second, y. I like this method because I was practicing an old skill, which is multiplying. And now I need to reduce. The nice thing is it goes into the 0. I know I can divide by 10. I actually can divide by 20, can't I? If I divide that by 20, I get a 3, and divide that by 20, I get a 2. Yeah, otherwise you just have to keep going, but it's fine to keep going. You could divide it by 2 or anything, or 5, whatever. You just had to reduce again. So we have a 3 on the top, a 2 on the bottom. The x's, I'm going to get an x to the third on the top, and the y's, I get a y to the second. You should have got that same answer if you did it here. That would be the simplified answer. And again, since there's no variables in your denominator, there isn't any exclusion. Variables has like an x or a y. If there's no letter down here, there's no number we have to worry about excluding. So we don't have any. And tomorrow we'll try to make it a little bigger than this. But so when you have a problem, I'm going to write slow so that I don't get ahead of you. The song's going to appear to go on forever. Oh no, we're not done yet. There, that's the problem. Open on pause. A little more work here. Again, this one is already done for you, and you would need to recognize that it's done for you. See how the double parentheses are already there? See how the A's already pulled out of this one? Times. This is very similar to what we just did. No, that's a 3. That's an A minus 7. They got a match, Paul. They got a match. This is an A plus 7. This is an A plus 7. They zap each other because when you have a fraction, whatever's on top, if it matches what's on bottom, it makes a 1. 7 over 7, 1. A over A, 1. A plus 7 over A plus 7, 1. So those got zapped. Anybody else find something else there? What else zapped? The denominator, A plus 5, and in the numerator, there was an A plus 5. So those would make each other 1s again. Leaving you with an A minus 7 on the top, because those 2's were gone, and an A with a 3 in front of it on the bottom. Why can't these two A's zap each other? These two. Carly? No. Please? That's part of it, yes. That's a new way of saying it, Michael. But the reality is this A is I call it tethered. It's almost like it has a little lifeline to the 7. So these two are clumped together, and the only way the A can get it to go away is if there was a minus 7 with it somewhere. So these two are stuck together. So A cannot equal 0 on this one.